the name of the Almighty, the Compassionate, the Merciful. Last lecture, in our last lecture, we spoke about the meaning of function, the concept of function, and how functions translate values of a certain set into another set. And we also have dealt with how the ways of calculating domain and range, etc., of functions. Now we move to another topic, the classification of these functions. What properties do they possess, etc., and what kind of operations are they performed on these functions. In fact, in this lecture we are going to speak about the following topics. First of all, we have to differentiate between algebraic and transcendental functions. What do we mean by an algebraic function, and what do we mean by a transcendental function? And then we shall talk about implicit as well as explicit functions, and can one transform from one another, etc. Then we speak about even and odd functions as well as monotone functions. And we speak then finally about ways of drawing some simple functions. Usually this is the topic that students like to know about, because they usually fear from drawing graphs of functions. And we shall indulge into this matter in detail and see how simple it is. If we consider these functions like the one above to the left, 4 times x to the power 1 over 9. This function, it's a third root of a third root. It's a kind of an algebraic function, and roots, in fact, are algebraic, lie in the form of in the domain of algebraic operations, because in the past the roots, etc., in the ancient times were supposed to be computed by algebraic operations. It's like, for example, to be able to transform rectangle into a square of same area, things of this sort. The one at its right is x plus 3 divided by 2x plus 1. This is also, it's an algebraic function we call it rational function. And the domain of such function is all values of x, so the exception of x is equal to minus 1 over 2. Whereas the one on the left hand side here, it's valid for r, because the square, the cubic root of x, if x is negative, exists, and since it exists, its third root also exists. Whereas the two below here, they are also algebraic functions, but they are of the so-called irrational functions, because we use square roots, etc. In fact, the irrational function of this sort, like square root of x inside the square root, etc. How do we know that these functions, these 4 functions are algebraic function? What do you mean by an algebraic function? In fact, since we know that all arithmetic operations are dealt with using algebraic operations, or numerical, or you can say all numerical calculations are dealt with using algebraic operations, then if we can calculate the value of f of x from x using the 5 algebraic operations, which are addition, subtraction, multiplication, division, and square root, then we call this function algebraic. In other words, if you can calculate x, f of x from x using these 5 algebraic operations, then we are in fact dealing with an algebraic function. A function of this sort, e to the power x, we call this exponential function. Again, this is a series representation of there are more than one series, of course, but a series of representation of such function. This is the most popular series to represent e to the power x, 1 plus x squared divided by factorial 2, etc. In fact, it looks like it is the addition of algebraic functions. Therefore, one may conclude that e to the power x is an algebraic function also. But this is not true, because when we say that an algebraic function is that function that one can calculate f of x from x using the 5 algebraic operations, we have to be more precise on that, and saying that you have to do this operation a finite number of times. We cannot perform this an infinite number of times. But here actually when we calculate e to the power x, then we have to sum the series indefinitely. And this is why e to the power x is not really an algebraic function. this is another. This is a polynomial. It's also an algebraic function. It's sum of finite number of times of x and x squared, etc., up to the x to the power n, where n is integer. And f of x, this has, as it looks like, this has domain R. And range, it can be positive, it can be R, etc., depending on n. Another one of this sort, like f of x, a rational function like this, it has as domain, could be R, with the exemption of those roots of the denominator. It looks here as if one has to make sure that the denominator is not 0. In other words, one has to search for the roots first and exclude those roots from the domain R of the function. Now, the functions, in fact, any function, must lie within this flow chart here, or this table. You can have a function is either, of course, algebraic or transcendental function. Now, by algebraic functions, as we said, we mentioned before, it has to, f of x has to be computed or calculated using the algebraic operations. And we differentiate between two kinds of algebraic functions. Either they are rational or irrational. A rational, like for example, 1 over x, or x plus 2 divided by x minus 1. This is called rational function. Or an irrational function, they don't have a certain form, they have so many forms, all of them contain roots and radicals, etc. The rational ones, they are integral, like polynomials, the one that we saw before, above in the last slide, or they may be fractional, like the one also in the last slide below. These are the what we call algebraic functions. Algebraic functions usually play a role in they are the majority of the functions that we encounter in engineering, etc. They are the sort form of algebraic function. But nonetheless, we also encounter transcendental functions. Also, they are either elementary or higher transcendental functions. In general, one in this such course, we don't encounter higher transcendental functions. They are the sort of, like for example, the one that we encounter in mathematical physics in general, like for example, solving partial differential